continuing our discussion of using GDB to investigate Linux stack buffer overflows, we have our little program loaded up here into GDB, and we've set a breakpoint, and we said, okay, I want to have a look at my program. I have a breakpoint. I can say info breakpoints, and it says breakpoint 1 is in function at line 9. That's right here after my stir copy call. I can run my program and give it some arguments. I'll give it 4 A's and 4 B's, and it goes right up to my breakpoint. So right after this stir copy call. Now I want to examine part of my memory. In particular, I want to examine my stack. So how do I do that? If you don't know what to do, you can always type help. And if you want help on a specific command, you can say help info, etc. And that works great. So in this case, I want to use the examine command. Now, because you use this command all the time, it has a nice abbreviation. It's just X. So I want to examine, and I'm going to tell it 20 things. I want to examine in hex 20 giants. A giant is 8 bytes long or 64 bits. The reason I'm going to do this is I'm actually running a 64-bit version of Linux here, and I want to make sure that I am printing out things in 8-byte chunks so that if I have something like an address or a pointer, that it will print it out correctly. What do I want to print? What do I want to examine? I want to look at the stack pointer. Now, we've talked about the stack pointer before, and we said if you have a 32-bit system, the stack pointer was called ESP, the extended stack pointer. Now, for a 64-bit system, it's called RSP. You can think of it as the really big stack pointer if you want. So I'm going to go ahead and print out the stack RSP, and I get this information. So what do I see on the stack? A couple of things you're going to notice. Here, these first two values, these look a lot like addresses. I see here that this address is close by. Here I'm at DD70, and this address points to E1C8, and this address points to E250. Then I see 4 42s and 4 41s. In other words, I'm seeing 4 A's and 4 B's. Now you might wonder, why am I seeing the 42s first? Remember that Intel is little endian. So all of the bytes are entered in reverse order. So when I said 4 A's and 4 B's, that's how it was entered, and it was just changed. It was flipped around because I said I want to look at it in 8-byte chunks. Now, one thing I'm going to do right now, I'm going to go ahead and I will copy this and I will put it into a little text editor for reference. So I'm going to select all of that and copy it. And now I'm going to go ahead and run a text editor, and I'm going to paste those values. And I'm just going to give myself a little note here that says this is the stack with no stack protector. And you might ask yourself, how does this differ if I have the stack protector? So let's go ahead and we'll go back to GDB, and I'm going to go ahead and exit. You can either quit or hit Control D. And now I'm going to rerun GDB. And in this case, the version without the stack protector. And again, if I list my program, it looks like so. The first program, I think I might have put an incorrect note in here that I ran. This is with the stack protector, and we'll see how it looks a little bit different without the stack protector. So we'll go back to our terminal. We'll set our breakpoint at 9. We will run it with the exact same input, A, B, 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 B. We go to our breakpoint. We will examine 20 hex values that are giants, and we will look at the stack RSP. Now I can copy and I'm going to paste into my document. So I will paste this, and this is without the stack protector. All right, so what's the difference? Notice that in both cases, this value is in the same spot. But here, without the stack protector, some of these other values are different. Now, this guy is 0, and where I formerly had something that looked like an address here and here, I don't have that. Now I have just a value of 1 and this guy. Slightly different address from what I have here. So the important thing to note is that the addresses will be different if you are using the stack protector or not. With the stack protector, there are some additional values that are put on the stack, and these are used to protect your program. So basically, what are these additional values doing for you? They are detecting if you've done something strange with the stack. Well, that's all for this video. We will take a brief break, and when we come back, we'll talk a little bit more about stack buffer overflows in Linux.